the background. Just to summarize, John, you may want to bring that over here, okay? Very carefully. You can bring that over. Bring that over so you guys can see this, okay? So what I covered yesterday was a very, very detailed analysis of a PowerPoint I'm going to bring up here, so it'll be easier for you, John. Hold on 1 second. Here. So I covered, this is a summary. I said, look, what happened? This is what I covered yesterday, why I was banned for this video. I said, look, in Franklin County, I won by 10 points, which was all primarily hand-counted paper ballots. All these other counties, I'm losing 60-40. And what I taught yesterday was, look, you need to understand what a system is as a systems guy. And I said, look, all systems have an input. Every system has an output. This was this is a professorial talk. And I said, an electronic voting system, the input is a number of people coming in to vote, which could be paper ballots, hand ballots, right? Mail-in ballots. That's P. And then I said the output is a number of V, votes. And then I proceeded to ask, should P equal V? Yes, the number of people voting, 1,000 people come to vote, you better have 1,000 ballots, votes cast. And what I shared was, when I knew that they committed election fraud with me in Massachusetts, I went to a sampling of various towns, and I, here are those, for example, 7 towns, and I asked the actual names of the people who voted, okay, which is called P, the participating voters. So, for example, in Boston, 142,911 people voted. In Newton, 30,284 people actually voted, okay? Then I looked at the actual ballots cast. Well, in Boston, you have 147,025 people who cast ballots, actual ballots. And in Newton, 32,064. Here's a problem. V is greater than P, okay? For example, in Newton right here, you have 1,780 more ballots cast, okay? Is that right? More ballots than people, all right? And here in Boston, 4,114 more. Bottom line, more votes than voters. So this is what I shared yesterday. And then I proceeded to basically teach people P does not equal V. And I shared that what I discovered in September was in these electronic voting systems, they can actually multiply P, which is the votes coming in, by a weight. It's called a weighted race feature. So if the weight is 1, then V equals P, right? P times 1. However, let's say the weight is greater than 1, then V will be greater than P. If the weight is less than 1 or 0, then V will be less than P. Bottom line is there's a feature. If you don't believe me, here is page 2-126 of the Diebold voting manual, the actual manual. Now the Diebold is important because Diebold is a company which is like sort of the great grandfather of all voting machine software. And this feature is in every voting machine software. It's called the weighted race feature. So look at page 2-126. What does it say? Weighted races. It's a feature. You can turn on the weighted race feature. It's one of the setups of the system. It says the weighted races are tallied by weights assigned from the voter registration, may be counted in central vote centers only. Okay? So they have a feature. So here I'm winning in the hand counted, but everywhere else I'm losing by 60-40. So as a part of this, I went to the Secretary of State. You can point here, John. I went to the Secretary of State because on the electronic machines, I wanted the ballot images, because if they don't save the ballot images, they did that because they wanted to hide the fact computer